Welcome back to the review of my channel, math_exe. Today we're going to look at parallel lines and angles. And this is a bit of introduction to, I would call this angle geometry, which I'm just going to make a playlist of like basic geometry. And this first part we'll talk about angle geometry. The second part we're going to talk about perimeter and area of 2D shapes, and then finally volume and surface area of 3D shapes. So for the first part, or I would say first chapter, to start it off, we're going to look at parallel lines and angles. So these contain like several terms that you might need to be familiar with. So let's just jump into it. So given two parallel lines intersected by a transversal L, so as you can see the diagram like so, and then there are some special angles built inside this setup. First is interior angles. So basically, the set of angles DE, so it's this part and this part, and CF, which is this part and this part, are pairs of interior angles with the property that the sum of a pair of interior angles must be 180 degrees. So if you look at this, these lines right here that make up a pair of the interior angles, it looks like a C shape, but it's kind of bent either to the left or to the right. And that C shape, that it can be also flipped backwards like so. So this is the other set of interior angles, or I would say pair of interior angles. So that's how you kind of identify a pair of interior angles in this setup. And the next special angles, or which is alternate angles, the set of angles CE, this one and this one, and DF, which is this one and this one, are pairs of alternate angles that satisfies the angle of the first angle must be equal to the second angle. So if you look at the lines that make each alternate angles, it looks like a Z. And sometimes that Z could be also flipped backwards, like just the interior angles one. So in this case, for the angles DF, it will be this right here, which looks a bit odd. It doesn't look like a Z. It kind of looks like this. But as you can see, as the name suggests, these angles are alternate to each other. So they form like this formation. And finally, the final special angles that you need to be familiar with two parallel lines and a transversal will be corresponding angles. So in this case, there are many corresponding angles. First one is AE, the next one is BF, then is CG, and then DH. And if you look at that setup, and I should have mentioned the property that if you have a set of corresponding angles, the first angle must be equal to the second angle. And if you look at the format, for the first pair of angles, which is AE, it looks like an upside down F. And for the second one, BF, it looks like a upside down F, but kind of like rotated a bit. And then you can just do it all on. And that's basically it for this thing. Alright, so next thing I'm going to talk about complementary and supplementary angles. So a pair of angles are said to be complementary if they add up to 90 degrees. So in other words, they form a right angle. So here's an example of angle A and angle B, and they are obviously complementary because they form a right angle like so. And for the second example, this is not in this case a set of complementary angles, and I would say it generally isn't because it could add up to 90 degrees. However, the setup here is incorrect. So we say angle Y and angle X are not complementary. Next is supplementary angles. It says a pair of angles are said to be supplementary if they add up to 180 degrees. So example is angle P and angle Q right here. And then here's a incorrect example right here. So notice that angle V is a part of angle U. As you can see, angle U is kind of like intersecting with angle V. So in this case, well, at least if you add them up, it will not result in 180 degrees. So here are some like easy ones. I would say general and easy ones. So let's see. The sum of all angles in a straight line. So here is the straight line right here. Is 180 degrees. So if you have like a load of angles in the straight line, and if you sum them all up, it will add to 180 degrees. So in this case, angle A plus angle B plus angle C plus angle D will be 180 degrees. And the sum of all angles in a point, so the point is right in the middle right there, is 360 degrees. So from this diagram, angle P plus angle Q and so on will result in 360 degrees. Alright, so that's it for the basics of this, and more about these angles, specifically for shapes and stuff, in the next video. And in that next video, I'm going to talk about angles in polygons and some special quadrilaterals. Alright, so let's jump into some examples. First question. So in the diagram below, A, B, C, D, and E, F, G are parallel. So it is denoted by this arrow sign on the lines. And usually these diagrams are usually not to scale. So that's just like a quick information for you. So we need to find the angles ABE, which is this segment right here, and then CDF. Alright, so first you can notice that the refrax angle at E is 330 degrees, and that means the acute angle at E must be 360 degrees minus 330 degrees by the sum of all angles in a point. So this will be 30 degrees. And then notice, although this might be not very obvious for you, is we have a Z shape right here, marked in yellow. And by alternating angles, this 30 degrees right here at E must be equal to this angle right here at B, specifically angle ABE. So this angle must be 30 degrees, and therefore our first answer must be 30 degrees. Alright, for the next one, it doesn't require any calculation at all. It's just need to like find some non-obvious patterns or possibly clues about parallel and transversal lines. So in this case, it is also in alternating angles. So notice that this forms a not so Z shape because it doesn't look like a Z at all. But in this case, by alternating angles, this angle right here, so it's DFG, must be equal to this angle in red, which is CDF. So this must be 150 degrees. Or an alternative method is, since we know this is 150 degrees, we can just calculate the rest of this by knowing that the angles in the straight line sum up to 180 degrees. So this must be 30 degrees. And then quickly noticing that this shape marked in blue is a setup of interior angles, and these pair of angles must sum up to 180 degrees, and that's also another way you can find angle CDF. So the answer in this case is 150 degrees. Alright, so that's it for the first question. Let's jump into the second one. Alright, this is the second question. So we know that AB is parallel to CDE, which is this segment and this segment right there. And then we know that BDG is parallel to EF. So it is this segment and this segment right here. And I've given a clue. CDE, BDG, and FDH are all straight lines. So first we need to find angle DEF, so I'm going to mark here, and then next is CDH, which is this little thingy right here. Alright, so first we can just calculate the reflex at ABD by knowing that the sum of angles at a point is 360 degrees. That means this but must be 360 degrees minus 315 degrees. That must be 45 degrees. And by knowing that this bit right here marked in green is set up for corresponding angles, and by corresponding angles, this 45 degrees must be equal to the angle CDG, so this must be 45 degrees. And then lastly, using corresponding angles yet again, we know that this forms a setup of corresponding angles. So that means this 45 degrees must be also equal to this 45 degrees. That means our first answer for this must be 45 degrees. And for angle CDH, well, we know that HDF is a straight line as mentioned in the question. Well, FDH in this case. So by knowing that the angles in a straight line sum up to 180 degrees, that means CDH is 180 degrees minus 45 degrees minus 35, which is 100 degrees. And just like I mentioned, this is not to scale, because if you see right here, CDH looks like an acute angle, but it's actually an obtuse angle. And that is for several reasons. Well, mainly one reason, because I'm drawing this on my iPad device, so it might be not as accurate as it is in reality. Alright, so that's it for the second question. Let's jump into the third one. Alright, here is the third question. In the figure below, VW is parallel to YZ, and I forgot to label Y here. So basically, VW is this segment is parallel to YZ at that segment, and then we need to find the value of this angle right here at XYZ. And first thing that most of you guys might have noticed that this acute angle at WXY must be 100 degrees, because the sum of all angles in a point is 360 degrees. And at this point, you might be screwed because there's not that much skews. However, if you draw a parallel line in intersecting point X, which is also parallel to VW and YZ, right here, you notice some special angles in true parallel lines, like I've just mentioned before. So the first thing is this bit and this angle right here. I'm just going to mark this as yellow. These two angles are interior angles, and therefore both of them must sum up to 180 degrees, and that means this part must be equal to 40 degrees. And since the whole thing in X must be equal to 100 degrees, and this little bit is 40 degrees, the other bit must be 60 degrees. And again, this 60 degrees and this angle right here are pairs of interior angles. So what that means is they sum up to 180 degrees yet again, and therefore the rest of this angle must be equal to 120 degrees. So sometimes you need to sketch some lines and stuff to find some angles, because after you reach a point that you realize that the built-in diagram doesn't have any that much clues, you can just make your clues by your own and see what you can get there. So anyways, let's jump into the fourth question. Alright, for the fourth question, in this case, AB is parallel to CDEF. So labeling this, so we have AB is parallel to CDEF, which is a straight line. And then we're also given that HBE and GBD are also straight lines. And from this diagram, we need to find the angles X, Y, and Z labeled right here. So first, let's start off with X, which is, I would say, is the pretty obvious one, because notice that we have HBE and GBD are straight lines, and therefore X and 99 degrees are vertically opposite angles, and that means they must be equal to each other. So that means X is 99 degrees. Alright, so the next one is Y, and this is also a pretty obvious one. So notice that 145 degrees and Y are sets of interior angles, and that means they must sum up to 180 degrees. And from this equality, we get Y is equal to 35 degrees. So I'll just write our answers so far. So I have X equals 99 degrees and Y is equal 35 degrees. Now Z is not so obvious one, but it is a pretty easy, it involves pretty easy steps. So notice that we can just first find this angle right here, which is BDE, and which is just 35 degrees, by knowing that the sum of all angles in a straight line must add up to 180 degrees. And notice that BDE is a triangle. So what that means is the sum of all angles in a triangle must be equal to 180 degrees. So that means the angle BED right here must be equal to 180 minus 35 minus 99, which is equal to, so let's just do this manually. So we have 0 minus 5, we take 1 out from 8, and then we have 9, which is 6, So we borrow 2 from here. 8 minus 3, 5. 5 minus 9 is 6. And 2, 46. So this angle is 46 degrees. And by the sum of all angles in a straight line, we know that z plus 46 degrees must be equal to 180 degrees. That leaves us z must be equal to 134 degrees. And that's the fourth question. Let's jump into the fifth and final question of this video. Alright, for the fifth and last question, it says that AOD, BOE, and COF are all straight lines, and BOE is parallel to AF. Alright, so we need to find first is angle DOE, which is this part in yellow, and then we have FAO, which is this part right here marked in red. Alright, so first quickly notice that we know that AOD and COF, which is this first set of angles that we're going to look at, are all straight lines, and therefore angle AOC, which we know is 90 degrees since it is a right angle, must be equal to angle DOF, which is the other side right here. And since we know this is 90 degrees, then this must also 90 degrees. So this must be also a right angle. And notice the whole thing at DOF is a right angle. And this little bit is 60 degrees. And therefore this little bit in yellow must be 30 degrees. Alright, that's it for the first part, which is DOE. So we know that the answer for part A will be 30 degrees. Alright, for the next part, and since we know AOD is also a straight line, that means this is also a right angle by knowing that the sum of all angles in a straight line must sum up to 180 degrees. Therefore, AOF, AOC, DOF, and in fact also COD must all be right angles. However, we're going to look at AOF first. And first notice that this 60 degrees and angle AFO are alternate angles, and what that means is AFO must be equal to 60 degrees. So that is another clue for this. And since we know that AOF is a triangle, and the sum of all angles in a triangle, specifically all interior angles in a triangle, is 180 degrees, you can find FAO. So this simply just becomes 180 degrees minus 60 degrees minus 90 degrees, which is the right angle right here. And calculating this is equal to 360 degrees, which is our answer for part B. Alright, so that's it for all examples and brief explanations of parallel lines and angles relating to parallel lines and all that stuff, like the terms that you need to be familiar with, like complementary and supplementary angles. So hopefully you guys enjoyed this. Please subscribe for more, and I'll see you guys in the next video. Goodbye.